The dealership never told you these exist, the owner's manual buried them in a language nobody reads, and the mechanics who know about them stay quiet, because informed owners are bad for business. 17 tricks. 0 trips to the dealer. 0 special tools. Every single one working on your Mercedes right now, untouched and waiting. Number 1. Changes everything. Let's get into it. Number 17. Disconnect the battery for 30 seconds and reset everything. Your Mercedes engine control unit accumulates adaptive data over time. Fuel trim corrections, idle speed compensations, transmission shift adaptations, all building up across thousands of driving cycles as the ECU attempts to correct for aging sensors and gradual mechanical wear. Over time, these corrections drift the engine away from its factory calibration baseline. Turn the ignition key to position 2, that's the dash lights, on position right before the engine cranks. Press the gas pedal all the way to the floor, past the kickdown button, and hold it there for 5 seconds. The engine relearns your driving patterns within the first 50 miles, after reconnection, but from a clean baseline rather than a corrupted one. Most Mercedes owners who perform this reset report noticeable improvement in throttle response and idle smoothness within the first week. The procedure costs nothing, takes 3 minutes, and requires only a 10mm spanner. Drive at least 15 minutes of mixed urban and highway driving before judging the results. The relearn cycle requires real driving data to complete. The battery reset clears what the ECU has learned incorrectly. Number 16 adds something the fuel system has been missing, and the difference happens within a single tank of fuel. Number 16. Run 1 full tank of ethanol-free premium fuel. American pump fuel is blended with up to 10% ethanol by volume, and the decision to blend it was made by agricultural policy committees rather than automotive engineers. The engines in Mercedes-Benz vehicles were developed, calibrated, and validated on European fuel specifications that carry 0 ethanol content, sulfur content capped at 10 parts per million, and a research octane number that exceeds what American premium pump fuel delivers by 3 to 5 points on an equivalent measurement scale. Every tank of American E10 fuel your Mercedes has consumed represents a combustion event conducted under conditions the engine was never designed to optimize around. Ethanol contains less energy per gallon than pure gasoline, produces different combustion characteristics than the fuel Mercedes engines were calibrated on in Germany, and accelerates injector tip deposit formation in high-compression direct injection engines. The deposit acceleration mechanism is specific and well documented. Ethanol combustion produces aldehydes and organic acids as byproducts that do not appear in the combustion products of pure gasoline. These compounds react with the carbon deposits already forming on injector tips from the direct injection carbon accumulation process described elsewhere in this list, creating a harder, more adhesive deposit layer that resists the cleaning action of fuel additives more aggressively than deposits formed on ethanol-free fuel. The injector tip deposits that form on E10 fuel are not simply more abundant than those forming on ethanol-free fuel. They are chemically different in a way that makes them meaningfully harder to remove once established. The moisture absorption characteristic of ethanol compounds this problem further. Ethanol is hygroscopic, meaning it actively pulls water vapor from the atmosphere into the fuel system wherever air contact occurs. That absorbed moisture enters the combustion chamber with the fuel charge and contributes to the water vapor load passing through the positive crankcase ventilation system and into the intake manifold, where it combines with oil vapor to create a more adhesive deposit precursor on the intake valve surfaces than dry fuel combustion produces. Ethanol-free premium fuel is available through puregas.org, which maps every retailer in America selling non-ethanol blended fuel by zip code. Running 1 full tank every 4 to 6 fills gives the fuel system a cleaning interval and allows the ECU to experience the combustion quality the engine was designed around. Fuel economy improvement on a single tank of ethanol-free premium in a Mercedes direct injection engine typically runs between 4 and 7%, largely canceling the higher cost per gallon. Ethanol-free fuel cleans from the combustion side. Number 15 cleans from the induction side, and what it removes from your intake valves will make you question every tank of fuel you have ever run through this engine. Number 15. Use a polyethyramine fuel. Additive every other tank. Polyethyramine, abbreviated PEA, is the active cleaning compound in Techrin Concentrate Plus and Redline SI1. On modern Mercedes direct injection engines, the fuel injector tips sit directly inside the combustion chamber exposed to blistering heat that bakes carbon fuel residue right onto the nozzle. Inside the combustion chamber at temperatures that bake fuel residue onto the tip surface with each firing cycle. As deposits accumulate, the spray pattern degrades, combustion becomes less complete, and fuel economy falls. One bottle of Techron added to a nearly empty tank, followed immediately by a full fill of premium, begins dissolving these deposits within the first 50 miles. Repeat every second fill. Fleet data from engineers running European direct injection engines in ethanol markets documents up to 15% fuel economy recovery after a 4-tank PEA cleaning protocol. If these tricks are already changing how you think about your Mercedes, subscribe right now and hit the notification bell. This channel follows the engineering data wherever it leads, and what is coming next is something no dealer will ever put on a service menu. PEA cleans what it can reach through the fuel system. Number 14 addresses what it cannot reach, and the fix costs under $30. Number 14. Clean the mass airflow sensor with dedicated spray. The mass airflow sensor measures air entering the intake manifold and sends that data to the ECU to calculate correct fuel delivery. As the sensor accumulates contamination from oily air filter bypass and intake dust, its readings drift slightly low. The ECU receives an undercount of incoming air and delivers a leaner fuel mixture than required, creating throttle response degradation, rough idle, and reduced fuel economy that most owners attribute to general aging. CRC Mass Airflow Sensor Cleaner costs under $15. Remove the intake duct, unplug the sensor, spray the wire element with 6 to 8 short bursts from 2 inches away, allow 10 minutes drying time, reinstall. 20 minutes total. No mechanical skill required beyond loosening 2 hose clamps. Owners cleaning a contaminated Mercedes MAF sensor consistently report improved throttle response within the first drive. If these fixes are giving you back performance you thought your Mercedes had lost to age, hit that subscribe button right now. Every video on this channel is built on real maintenance data and real owner results. The MAF sensor measures incoming air accurately once it is clean. Number 13 optimizes what happens to that air before it reaches the combustion chamber, and most Mercedes owners have never touched this adjustment in their entire ownership. Number 13. Retorque the intake manifold bolts at 80,000 miles intake. Manifold gaskets compress permanently under bolt clamping load over years of heat cycling. Process is so gradual and so silent that most Mercedes owners have no idea it is happening until a smoke machine at an independent shop reveals the leak that has been developing for years. The physics behind this failure are straightforward. When the intake manifold is assembled at the factory, the gasket material is compressed to its designed thickness under the specified bolt torque. Over the subsequent years of ownership, every cold start and every heat soak cycle subjects the gasket material to thermal expansion and contraction that slowly takes a permanent set in the compressed fibers. The gasket does not fail catastrophically. It simply becomes incrementally thinner than it was when new, and the bolt clamping load that was correct for the original gasket thickness is no longer sufficient to maintain a perfect seal against the thinner, permanently compressed material beneath it. The bolts lose a small percentage of clamping force as the gasket takes its permanent set beneath them. A manifold with reduced clamping develops micro leaks that introduce unmeasured air into the intake stream, bypassing the MAF sensor entirely. This creates a lean condition the ECU cannot fully correct, causing rough idle, light throttle hesitation, and fuel trim numbers pushed to their correction limits. What makes this failure particularly difficult for owners to diagnose without equipment is that the micro leaks it produces are invisible and inaudible under normal conditions. Unlike a cracked vacuum line that produces a distinct hiss or whistle at idle, a micro leak across a slightly under-torqued manifold gasket face is too small and too distributed to produce any noise the driver can detect from inside the cabin. The only evidence available without diagnostic equipment is the rough idle, the hesitation, and the fuel trim data, readable through an OBD2 scanner, all of which have numerous other potential causes that get investigated and cleared before anyone thinks to check the manifold bolt torque. The ECU's fuel trim response to this condition is instructive for anyone with access to a scan tool. A healthy Mercedes engine running correctly on properly measured air will show short-term fuel trim values within plus or minus 5% of zero at idle. An engine with manifold micro leaks introducing unmeasured air will show short-term fuel trim pushed consistently toward positive 10% or beyond as the ECU attempts to compensate for the lean condition it is detecting through oxygen sensor feedback. That fuel trim reading, alone visible on any basic OBD2 scanner, is a diagnostic fingerprint for this exact problem. A torque wrench and the manifold bolt specification from a Mercedes service manual is all that is required. Most Mercedes 4- and 6-cylinder engines specify between 7 and 10 Newton meters for the intake manifold bolts. Retorquing takes under 30 minutes with basic tools and restores factory seal integrity, without replacement gaskets in most cases. The correct procedure is methodical rather than rushed. Work from the center, bolts outward in a crossing pattern, the same sequence used during original assembly, applying the specified torque to each bolt in sequence before moving to the next. This pattern ensures even clamping load distribution across the full gasket face, rather than creating pressure concentrations at individual bolt locations that can actually worsen the sealing condition if the retorque is performed randomly. The intake manifold seals the air charge entering the engine. Number 12 addresses what is escaping on the other side, and what is leaking out right now is costing you measurable fuel economy every week. Number 12. Inspect and retorque the exhaust manifold studs. Exhaust manifold studs on Mercedes engines, particularly the M272 and M273 families, experience extreme thermal cycling that gradually reduces clamping force on the manifold gasket. A weeping exhaust manifold leak produces a ticking noise loudest on cold start that fades as the manifold expands with heat, leading most owners and mechanics to investigate the valve train instead of the correct location. An exhaust manifold leak also introduces atmospheric oxygen into the exhaust stream upstream of the oxygen sensor. The sensor reads this as a lean combustion event and richens the fuel mixture inappropriately, increasing fuel consumption from an engine that is running correctly but receiving bad sensor data. Carbon tracking radiating outward from the gasket edge is the visual confirmation. New studs and a replacement gasket cost under $60. The fuel economy and idle quality recovery is immediate. The exhaust manifold affects what the oxygen sensor reads. Number 11 affects what the throttle body delivers. And this cleaning has probably never once appeared on a service invoice for your car. Number 11. Clean the throttle body every 30,000 miles. Oily vapor from the positive crankcase ventilation system deposits carbon and varnish on the throttle bore walls and butterfly plate over time. A dirty throttle body causes erratic idle, hesitation off throttle, and forces the ECU to maintain higher idle bypass airflow than necessary to compensate for the restriction. CRC throttle body cleaner, applied through the throttle bore with the butterfly valve held open, manually dissolves the deposit layer effectively. Wipe the bore walls after 2 minutes of soak time. Do not spray into a running engine. 15 minutes, under $12. After cleaning, the ECU requires approximately 30 minutes of mixed driving to recalibrate idle control. The idle may hunt slightly during this relearn period before stabilizing. A clean throttle body flows air correctly at every operating point. Number 10 addresses fuel pressure on the other side of that throttle body, and this is one almost no independent shop ever thinks to check. Number 10. Inspect the PCV, breather, and crankcase hoses. Instead of checking a non-existent vacuum line on modern electronic fuel rails, look at your plastic PCV breather hoses. This small diameter hose is almost never inspected during routine service. Over time, it develops micro cracks from heat cycling and loses its ability to transmit manifold vacuum accurately to the regulator diaphragm. A cracked vacuum line causes the regulator to operate at fixed pressure regardless of load. The result is rich, running at idle, and lean, running under load simultaneously, degrading fuel economy and stressing the catalytic converter. Replacement hose costs under $5 per foot. A 15-minute inspection and $5 repair resolves a fuel delivery issue that dealers routinely misdiagnose as a failing regulator costing several $100s. The fuel pressure regulator ensures correct delivery. Number 9 ensures the spark that ignites that delivery is as strong as the day the engine left the factory. Number 9. Inspect coil pack boots for oil contamination. Mercedes ignition systems are incredibly robust, but the valve cover cam, seals, and spark plug well gaskets are notorious for weeping oil as they age. Over their service life, the electrode erodes and the gap widens. A widened gap requires higher coil voltage to jump the increased distance, drawing higher primary current that shortens coil life while reducing ignition energy delivered to the combustion chamber. A feeler gauge set costs under $10. Checking plug gaps at the service halfway point takes 15 minutes on a 4-cylinder and 25 minutes on a 6-cylinder. Plugs within 0.02 millimeters of specification need no action. Plugs beyond that threshold should be replaced early. Gap checking between intervals maintains ignition energy at specification and extends coil life simultaneously. Correct plug gaps keep ignition strong between intervals. Number 8 protects the engine during the intervals when it sits completely still, and the technique costs nothing beyond the slightly early oil change. Number 8. Store the car with fresh oil before any layup. Period-used engine oil contains combustion acids, suspended wear particles, fuel dilution products, and moisture. While the engine runs, these contaminants are held in suspension, and moisture is driven off continuously by operating temperatures. During a stationary layup period, they settle and concentrate against metal surfaces. Combustion acids attack bearing surfaces. Moisture combines with sulfur compounds from blow-by to form dilute sulfuric acid that etches cylinder walls and bearing journals over weeks of storage. Changing the oil immediately before any layup period of 30 days or more ensures fresh additive chemistry protects all internal surfaces during storage. This is standard protocol in Mercedes factories' storage preparation documentation for vehicles entering transport or dealer inventory and is almost universally ignored by private owners. Most Mercedes owners will never know this. The ones who do are watching this channel. Hit that subscribe button so you never miss what the dealership is not telling you. Fresh oil protects during storage. Number 7 protects during every cold start, and the product that enables it costs under $20. Number 7. Shorten your oil change interval to 5,000 miles. Mercedes MB 229.51 and 229.52. Specification oils contain lower zinc dialkyl dithiophosphate concentrations than the oils these engines were originally developed on, necessary for catalytic converter longevity, but representing a genuine reduction in boundary lubrication protection. At cold start, when metal surfaces make brief contact before full hydrodynamic oil film pressure builds, shifting to a strict 5,000 miles or 6-month oil change interval keeps the oil viscosity exactly where the variable valve timing system solenoids need it. Under $20 per bottle, one bottle treats 2 oil changes at the correct dilution ratio. The protection benefit is highest in ambient temperatures below 40 degrees Fahrenheit, where cold start oil viscosity increases substantially. Oil stabilizers address the cold start lubrication gap. Number 6 addresses the combustion deposit gap that builds as engines accumulate mileage, and the technique requires nothing beyond the right driving conditions and a clear stretch of road. Number 6. Perform a monthly Italian tune-up on a clear highway. The Italian tune-up uses high-load, high-temperature operation to burn off carbon deposits from intake valves, combustion chamber surfaces, piston crowns, and oxygen sensor tips. Wait until the engine is fully at operating temperature. Find a clear legal stretch of highway. Select third gear at 60 miles per hour using the paddle shifters, and apply strong progressive throttle through the RPM range up to 5,000 RPM, well below red line on every current Mercedes engine. High-load combustion raises chamber temperatures to the point where carbon deposits soften and oxidize. High exhaust gas velocity physically scours loosened deposits from valve seats and exhaust ports. 3 to 4 runs over 10 minutes provides combustion cleaning that no additive alone can replicate because it requires the combination of heat and gas velocity simultaneously. Perform this once per month on any drive that already includes highway mileage. It costs nothing. The Italian tune-up burns deposits from inside the combustion chamber. Number 5 removes something from outside the engine that is actively strangling airflow right now. Number 5. Wrap the intake tube in reflective heat shielding. The intake air tube on most Mercedes engines runs in close proximity to the engine block and exhaust manifold. Factory heat shielding reduces but does not eliminate heat transfer to the intake air column. On a fully heat-soaked engine bay, intake air temperature between the intercooler outlet and the throttle body can run 15 to 25 degrees Fahrenheit above ambient, reducing air density and combustion potential with every intake event. Reflective fiberglass heat wrap applied to the intake tubing costs between $20 and $40. Remove the intake tube, wrap it, secure with the provided clamps, reinstall. 40 minutes total. Cooler intake air improves combustion density on naturally aspirated engines and reduces intercooler thermal load on turbocharged variants, allowing the intercooler to operate more efficiently across a wider range of ambient conditions. Cooler intake air feeds better combustion. Number 4, feeds better combustion at the molecular level by addressing something in the fuel delivery system almost no Mercedes owner has ever considered. Number 4, Upgrade to a higher flow fuel filter on high-mileage cars. Mercedes factory fuel filters are designed for factory standard fuel demand at factory power levels. As injectors accumulate deposit buildup and require higher fuel pressure to maintain correct delivery, the factory filter becomes a mild flow restriction at peak demand moments. A high-flow fuel filter meeting the Mercedes Micron specification, but with higher flow rate capacity cost between $30 and $60 through ECS tuning or Pelican parts. Depressurize the fuel system by pulling the fuel pump fuse and cranking the engine until it stalls before disconnecting any fuel lines. On high mileage, Mercedes above 100,000 miles, combining a high-flow filter with the PEA additive protocol addresses both delivery volume limitation and injector cleanliness simultaneously, restoring a fuel delivery system operating closer to factory specification than either intervention achieves individually. Better fuel delivery feeds cleaner combustion. Number 3, delivers cleaner combustion signals back to the ECU, and the component it involves is one most owners have never once considered inspecting. Number 3, clean the oxygen sensor. Threads before any sensor replacement. When an oxygen sensor fails and requires replacement, almost no technician cleans the bung threads before installing the new sensor. Exhaust bung threads accumulate carbon fouling, heat scale, and corrosion products from years of exhaust gas exposure. Installing a new sensor into contaminated threads torques unevenly, creates microgaps at the seating interface, and introduces exhaust leak paths around the new sensor body that defeat the accuracy of the very sensor just installed. A thread chaser of the correct size, typically 18mm by 1.5 thread pitch on most Mercedes models, costs under $15. Running it through the bung before installation ensures correct thread engagement, proper torque to 30 to 45 Nm, and a leak-free seal. A correctly seated oxygen sensor provides accurate feedback to the ECU from the first drive. An oxygen sensor installed in contaminated threads does not, regardless of how expensive it is. Correct oxygen sensor seating ensures accurate fuel feedback. Number 2 addresses the ignition feedback that works alongside that fuel signal, and the improvement is immediate from the first start. Number 2. Install a ground strap upgrade on high-mileage cars. The electrical ground system consists of multiple chassis ground straps, providing the return path for every electrical circuit in the car. Over high mileage, these connections accumulate corrosion at contact interfaces, increasing resistance in the ground path and reducing signal integrity across every sensor, actuator, and control module simultaneously. Degraded grounds produce symptoms that look like multiple unrelated electrical faults: erratic idle, intermittent sensor codes, transmission hesitation, inconsistent ignition timing, all potentially originating from a single corroded ground strap. Supplemental ground strap kits for Mercedes models cost between $30 and $60 through Amazon and performance retailers. Clean existing ground contact points with a wire brush before installing supplemental straps. Owners of high mileage Mercedes who install supplemental grounds consistently report improvements in idle stability, throttle response, and resolution of intermittent fault codes that persisted through multiple sensor replacements because the sensor was never the actual problem. Better grounds improve every electrical signal simultaneously. Number 1 ties every trick on this list together into a single protocol that protects everything at once. Number 1. The cold start protocol that protects everything. Simultaneously, every trick on this list addresses a specific system in isolation. Number 1 is the protocol that protects all of them simultaneously by controlling the single most damaging event your Mercedes engine experiences in its entire service life, which is the cold start. More wear occurs in the first 30 seconds of a cold start than in the subsequent 30 minutes of normal driving. Oil is cold and thick, pressure builds slowly, combustion temperatures are low. Every vulnerability on this list is at its maximum in that first 30-second window. The complete cold start protocol is 5 steps, taking 30 seconds total. Turn the ignition to the accessory position for 5 seconds before starting to allow the fuel pump to prime the fuel rail to full pressure. Before the first injection event, start the engine without touching the accelerator. Allow a 30-second idle at no load before engaging any electrical accessories. Select drive after 15 seconds of idle on automatic transmission models, allowing transmission fluid to begin circulating before the first gear engagement. Drive gently below 2,000 RPM for the first 2 miles, regardless of ambient temperature. This protocol eliminates the peak wear window. It allows oil pressure to build fully before any load hits bearing surfaces. It allows transmission fluid to circulate before clutch pack engagement. It allows the alternator to reach stable output before full electrical load, 30 seconds longer than your current morning routine. Years of additional engine life in return. 17 tricks. Every single one working with your existing car. Every single one backed by engineering logic your dealer has never once volunteered. The difference between a Mercedes that reaches 200,000 miles and one that needs an engine at 120,000 is not luck. It is the 30 seconds you spend at every cold start and the 15 minutes you invest in understanding what your car actually needs. Thanks for watching. If this list changes the way you approach your next drive, subscribe and hit the notification bell so you never miss what comes next. Click on the next video, already loading on your screen right now. We will see you there. Drive smart. Spend less. Make your Mercedes last.